When a lot of data is being collected, is to graph the data. It's important to graph the data so that you can find out any important features in that data, which may indicate something about what is being measured or something about how it is being measured. So you'll have done all of this sort of graphing before, I'm sure, in maths, so this should be just a little bit of revision. First of all, we need to go over plotting points on the Cartesian plane. Just remember, first of all, that points on a graph are written as an ordered pair x, y. The x coordinate always goes first, the y coordinate always goes second. So looking first of all at point A on the graph, we see point A is level with 2 on the x-axis and 4 on the y-axis. So we write it as 2, 4. Point B is level with -1 on the x-axis and 2 on the y-axis. We write it -1, 2. Point C is right on the x-axis. So it is level with 3 on the x-axis, that's where it is, at 3 on the x-axis, and it is level with 0 on the y-axis, so its y-coordinate is 0. When we plot data, a number of points, often we need to find the line of best fit and find the equation of that line. So the first thing we do when we get a graph like this is, of course, to scale the axis. Put numbers along the x-axis and the y-axis. Now we see we need the numbers from 1, we'll go from 0 to 5 along the x-axis. Unfortunately, we can't do better than just counting up by ones along there. We need to go up from 0 to 15 on the y-axis, so we're going to have to count up by 2's. So that's the first job, scale the axes. Next thing, we need to plot all the points. The first one is x equals 1, y equals 3. Level with x equals 1, level with y equals 3. Goes there. Next point is 2, 6. Level with x equals 2. Level with y equals 6. Then 3, 9, 4, 12, and 5, 15. Now that we've got all the points plotted, we can rule a line of best fit. Now, if we're to get the equation of that line, the easiest way to do that is to extend it down to the y-axis and make sure it crosses the axis there. And I've extended it. So we see these points fall exactly in the line, so that's easy to draw that line of best fit. Now the first thing we need to get the equation of a straight line is the y-intercept. The point at which the line crosses the y-axis. That is C in that form on the equation. So we see the line actually crosses the y-axis at the origin. I think the thing to do is to work out the gradient of the line in. Once we've got it, prediction. An extrapolation is a prediction past the last point, beyond the range of the data, either up this end or possibly down this end as well. That's our prediction, that's our extrapolation. Less accurate because it's outside the range of the data.